Now that the Perseverance rover has started to collect the first samples, that has kicked off the Mars Sample Return mission.
The goal of Mars Sample Return is to pick up those samples from Mars and bring them back to Earth.
This mission has many crucial components involving many NASA centers as well as international partners. The tests we're running right now are just the first step in making this mission possible.
What this testbed is working to achieve is early prototype drop tests for the sample retrieval lander that's going to go pick up the rock samples on Mars. 3, 2, 1.
After we've landed on Mars, the samples have been transferred into the Mars Ascent System.
We take the rocket and we actually throw it up in the air before we light it off.
It's an ambitious effort because we've never done this before.
Sequence are armed. 3, 2, 1, fire.
This test that we just did goes a long way to showing that it's possible.
That this is the correct path to go down to have a successful launch on Mars.
Once the samples have left the surface of Mars, they will be captured by the Earth Return Orbiter, where they will be safely contained so they can be brought back to Earth.
This particular tower is designed to test out one of the last elements of Mars Sample Return, this impact landing on Earth.
3, 2, 1.
We get to demonstrate how strong these hardware elements are to prove that these samples can be brought back safely, that we design a system that can stay contained and keep these Mars materials separate from the Earth's biosphere. We're still in the development phase right now, and so we're still using these tests as a learning mechanism.
We need to note the information to make sure that we can make a mission on another planet work.
In order to accomplish goals such as bringing samples back from Mars, you have to sometimes dare mighty things.
NASA wants to know, what does Perseverance mean to you? Our Perseverance Mars rover and mission teams already know quite a bit what it means to persevere. We found a way to launch the rover from Earth in the middle of a global pandemic. And since surviving the trickiest Mars landing yet, we've continued to overcome unexpected challenges in day-to-day operations and collecting and storing our first rock samples for future return to Earth. When you set your mind on a goal and stick to it, you can accomplish almost anything. Do you know someone who has perseverance? NASA is looking for nominations of middle school students from around the country who've kept moving forward when the going got tough. The You've Got Perseverance Award highlights the grit and determination of the next generation of explorers. Awardees will get to chat with NASA experts and even get a once-in-a-lifetime personalized message direct from the Perseverance rover on Mars. We can't wait to hear how you've got perseverance.
Seasons change even on Mars. A look at how NASA's explorers study the weather and cope with change, especially in the case of the Ingenuity helicopter, which now has to fly in a thinner atmosphere. This visualization, known as NASA's EYES, shows where the agency's 2 rovers and lander are touring the planet. For most of them, measuring the weather is a key part of their job. It's early summer in Jezero Crater, where NASA's Perseverance rover and the Ingenuity helicopter are exploring the South Sator region. Perseverance uses its Mars Environmental Dynamics Analyzer, or MEDA, to measure temperature, humidity, wind speed, and direction. These wind sensors also measure the amount and size of dust particles in the atmosphere, helping scientists understand the dust cycle and its impact on weather. MEDA also provides the Ingenuity helicopter with critical pre-flight weather forecasts. Recently, warmer temperatures and a thinning atmosphere have made it more difficult for the helicopter to generate enough lift to fly. its rotors had to spin faster than they had in previous flights, roughly 2,700 revolutions a minute. In the southern hemisphere, where the Curiosity rover is driving in Gale Crater, it's early winter. The Rover Environmental Monitoring Station, REMS, provides daily weather reports and takes regular dust surveys to measure seasonal changes over time. The InSight lander is focused on what's happening below ground. In September, it measured one of the biggest, longest-lasting Mars quakes ever detected. Seismic waves from the magnitude 4.2 shook InSight for nearly an hour and a half. Finally, the fleet of orbiters, including Odyssey, the Mars Reconnaissance Orbiter, and MAVEN, help scientists understand the scope and scale of storms from above. MRO produces a daily global weather map and provides us with amazing images. If you're interested in dunes on other worlds, check out these recent photos. To get the latest updates, follow @NASA-JPL and @NASA Mars on social media. Or take a deeper dive on the mission websites at mars.nasa.gov.
On NASA's Perseverance Mars rover, we have not one, but 2 microphones. And these microphones are the very first instruments of their kind ever to go to Mars. I'm Nina Lanza, and I'm a scientist at Los Alamos National Laboratory.
Hi, I'm Justin Mackey, an imaging scientist at NASA's Jet Propulsion Laboratory. One of the microphones is mounted on the mast and moves around as we point the cameras. The other microphone is mounted to the rover body, and it stays fixed onto the port side of the rover.
The 2 microphones that we sent were commercial off-the-shelf items. So these are things that you could just buy on the internet, and we put these on our rover.
It gives us a new dimension for which we can explore Mars and learn about the Martian environment.
First, we can just learn about the atmosphere by understanding how sound propagates through it. But we can also listen to the sounds of rover analyses on rocks and learn about rock material properties from that. And finally, we can also listen to the sounds the rover makes to understand better the state of health of our instruments.
There's a difference between Mars and Earth sounds. Sounds on Earth have very rich harmonics. You can hear multiple frequencies. It gives a really nice depth to the sound. On Mars, the atmosphere attenuates a lot of those higher frequencies, so you tend to hear the lower frequencies, and it's a much more isolated sound, a little more muted than the sounds we hear on Earth.
We've put together a list of some of the sounds we've recorded on Mars to date, so let's take a listen.
This is the sound of wind on Mars. For the first time, we can hear the wind blowing across the surface of Mars to go along with all of the images that we've acquired of dust devils and dust storms over the many years of exploration on the surface.
This is the sound of the rover driving on Mars. This sound might be a little bit weird because it doesn't sound like a regular driving sound, but that's because the rover's wheels are made of metal. So this metal is rolling over rocks and sand, and it makes this really clanky, squeaky sound.
Next, we have the SuperCam laser zapping rocks. We've taken a lot of pictures of rocks that have been zapped by the SuperCam, the little marks in the rocks, and for the first time we can hear these laser shots.
When it zaps a rock, it actually makes a sound. We can listen to that sound and learn something about the properties of the rock that we're analyzing. This is one of my absolute favorite sounds. This is the sound of a helicopter flying on Mars. We used this sound to actually understand the propagation of sound in general through the Martian atmosphere. And it turns out that we were totally wrong with our models. The Martian atmosphere can propagate sound a lot further than we thought it could. We've all seen these beautiful images that we get from Mars, but having sound to be able to add to those images, it makes me feel like I'm almost right there on the surface.
NASA's Perseverance rover recently successfully sealed and stored the first 2 rock samples from Mars. One of the ways the rover analyzes the rocks it's sampling is with the Sherlock instrument and its camera, Watson. This detective team studies rock surfaces and building blocks of ancient life. To learn more, we are joined by Eva Scheller, who is part of the instrument science team. Eva, what is Sherlock and how does it help pick which rocks are worth sampling?
Sherlock is a really amazing instrument. It actually stands for the Scanning Habitable Environments with Raman and Luminescence for Organics and Chemicals. It has 2 components. One is a very good camera called Watson, and the other is Sherlock itself, which is actually an ultraviolet laser that we use to characterize the mineralogical compounds and organics on the Martian surface. And that tells us whether a particular rock is worth sampling or not.
So what has Sherlock told us about the rocks of Jezero Crater so far?
Sherlock has made really amazing discoveries. We now know that these rocks derived from a volcanic environment and that there was liquid water there in Mars's past that formed salts that Sherlock has seen. And that actually has let us know that the samples we've just taken could have formed in an ancient habitable environment.
Now, looking to the future, what role will Sherlock play in the search for ancient life?
Sherlock is a very important instrument for 2 reasons. The first is that Sherlock is the only instrument that can directly detect organics, our building blocks for life, and we're always looking for organics in the samples we're taking. The second is that because Sherlock characterizes the chemical composition of the rock, that helps us understand whether any samples formed in an ancient habitable environment.
Well, thank you so much for joining us today, Eva. To get the latest updates, follow at NASA JPL and at NASA Persevere on social media and on the mission website, mars.nasa.gov/perseverance, where you can also find all the raw images being sent back by the rover.